Assalamualaikum. My name is MUHAMAD AFZAN BINTI AQMAL, and my matrix number is CE200122, and I will present for our group assignment, which is to prove the answer in the software. So I using as we can see at the screen, I using Maple software. So to prove the answer in the manual calculation, so this is our manual calculation. So to prove the answer in the software, so we arrange the equation, we type again in the software. So after that, just click enter, and then to make the final answer, we copy the answer, we copy the question into the equation. So this is the answer for the question 1A. So as we can see back to the manual calculation, it is same, and we prove the answer is correct. For the question 1B, they already write into the software. Okay, so right click, and then to prove the answer with the manual calculation. Okay, right click for the question, and then click the solve button, and then just click, and then this is the answer, final answer for the this is the final answer for the question 1B in the software. And compare with the manual calculation, which is y equal to x power of 3 over 2 plus c over x. Okay, and the answer almost same, that arranged into the final question, but in this software until here only. Okay, so
next, this is for the question 2. The question is to determine the solution of y double prime minus y prime equal to exponent to x minus x plus sin x using the method of undetermined coefficient. Okay, so we can see here the equation given is a non-homogeneous equation, and then the way to solve this, the first step is we need to make the fx into 0, and then I change it so that it will become a quadratic equation, and then when we solve it, the m1 we get is equal to 0, and then m2 is equal to 1. And then in this case, it is a case 1, which is m1 is not the same with m2. So the general solution that we get is yc, which is a plus bx. Next part is I separate the exponential with the trigonometry part, and then I combine the exponential part with the polynomial. So the first fx is equal to exponent to x minus x. That is for the yp. And then the polynomial is the same with the yc, so I multiply it by x, and then we get the yp1. So the next is the trigonometry part. It is not the same with yc, so we can proceed. So for the yp1, we need to differentiate it 2 times, so we can get the yp1 prime and then yp1 double prime, and same goes to the yp2, which is yp2 prime and yp2 double prime. So the next step is we compare the fx with the yp. So the first I compare with the first fx, the first yp, which is the exponential with the polynomial. So I plug in into the initial equation, and then we compare it. We take out the exponent to x, and then we get the c, which is 1 over 2. We get the x, which is minus 1 over 2, and then we get the x power of 0, which is e equal to 1. And then we compare for the fx of trigonometry, which is fx equal to sin x. We take out the sin x, and we get g equal to minus 1 over 2, and f is equal to 1 over 2. And then with all of the equation that we get, we can plug in into this formula, and then the general solution that I get is y equal to a plus bx plus exponent to x over 2 plus x square over 2 plus x plus 1 over 2 cos x minus 1 over 2 sin x. So we move on to the next question, that is using a version of parameter, which is the next method that will produce the same solution as the previous question. So the first thing that I did is I obtained a, which is 1, and then fx, which is equal to exponent to x minus x plus sin x. And the yc is equal to y1 plus y2. So in order to get y1 and y2, we need to make, same as before, we need to make it into a quadratic equation. So the m1 is 0 and then m2 is 1. So in this case, it is not the same. M1 is not the same with M2. So we get the YC, which is A plus B exponent X. And A is the Y1 and B exponent X is the Y2. We didn't take the coefficient, so we just left with Y1 is equal to 1, and then the Y2 is equal to exponent X. And then we did the Ronchian equation into a matrix form. Y1, Y2, and then Y prime 1, and then Y prime 2. So we cross multiplied it and we got exponent x. The next step is we need to find u and v. So for the u, we use this formula and then plug in all the equation that you get into this formula. For this u, I get a minus exponent to x over 2 plus x square over 2 plus cos x plus a. And then the next step is we need to find the v. And then same as before, we need to plug in all the equation that we get into this formula, and then but this time it is not easy to solve. So what I did is I solved each of these integration by using partial integration, which uses this formula, which is uv minus integration of v du. For the first part, it is exponent x plus c. And then for the second part, it is minus x plus 1 over exponent x plus c. And then for the last part, what I get is minus sine x minus cos x over 2 exponent x plus c. And then we plug in all the solution that we get into this v, and what we get is exponent x plus 1 over exponent x minus sine x plus cos x over 2 exponent x plus b. Okay, so the formula for the general solution is y equal to u y1 plus v y2. So we plug in all the equation that we get into this formula, and then we get this one. So we solve this, and then the final one we get a plus bx plus exponent to x over 2 plus x square over 2 plus x plus 1 over 2 cos x minus 1 over 2 sin x. And this is the same like in the previous undetermined coefficient that I get on the first question, which is question 2a. To prove my manual calculation on question 2, I'm using MATLAB. The first line is SYMS, which I'm using to declare y variable with an input of x. The second line is hypersign and letter s, which have a function of dissolve and a parameter of the equation, which is y double prime minus with y prime equal to exponent to x minus x plus sine x. And the third line is a function called pretty, which we'll use to make the code readable. So if we run this code, and then the output will be given, which is the answer. That is exponent x in bracket exponent x over 2 plus x exponent negative x plus x squared exponent negative x over 2 plus exponent negative x times cos x over 2 minus exponent negative x and x over 2 plus c1 exponent negative x close bracket plus c2 exponent x, which has proven my manual calculation.
Hi, my name is NURATHIRAH. So today I would like to present the calculation for question 3. So this is question 3. Given a non-homogeneous system of the first order linear differential equation as shown. So it has 4 questions. Question A, Evaluate the general equation of the homogeneous system. So step 1, write in matrix form y prime is equal to ay plus t. Step 2, find the eigenvalues and the corresponding eigenvector of A. Then step 3, check whether the corresponding eigenvector is linearly independent or not. Step 4, write the general solution for homogeneous system. Next, we move to question B. B. Determine the particular integral for the non-homogeneous system. Step 1, we assume yp. Step 2, obtain y prime p. Step 3, compare y prime p from step 2 with y prime. Now we go to question C. First, we formulate the general solution for the non-homogeneous system. Then we go to question D. Calculate the particular solution for y1x and y2x with y0 is equal to 1 over negative 1. So this is the simulation for question 3. This is the question and the equation that we need to solve it. For question A, we need to evaluate the general equation of the homogeneous system. So step 1, write in matrix form using the formula of y prime is equal to ay plus t. So we assume that A is the matrix form. So for A, we take the value of y1 and y2 for first equation and also y1 and y2 for second equation. Then we solve it. Okay. Step 2, we find the eigenvalues and the corresponding eigenvector of A. So this is how we find the eigenvalue of A. Then we solve it using the formula. Then we got equation 1. Equation 1, we solve it to get y1 and x1. Meanwhile, equation 2 to get y2 and x2. Then, after we substitute, we solve the equation, we have to find yc. Find general equation of yc using the for homogeneous system. So this is the equation for yc. Okay. After that, we move to question B. The question is determine the particular integral for the non-homogeneous system. Step 1, we assume yp. Step 2, we obtain yp prime. Step 3, we compare yp prime and with y prime. Then we solve it. So you will get this answer for U1. Then for question C, we just formulate the general solution for the non-homogeneous system. So this is the equation to find the general solution for the homogeneous system. Y is equal to yc plus yp, then we solve it. After that, we calculate the particular solution for y1x and y2x with y0 is equal to 1 over negative 1. So this is the answer for stimulation question 3. Thank you.
Hello, my name is Shahrul Nizam bin SABRIE, matric number DE 2098. and I'm going to present about the manual calculation for question 4. First of all, from the given the question 4a, given the differential equation y double prime minus 8y prime plus 3y equals to ft. And the first question, it asks us to find the piecewise function of ft, and then we have to find the Laplace transform ys of the differential equation with initial values when t is equals to 0, y equals to 1, and y prime equals to negative 2. For a1, we will have to do it like this. Find the piecewise function, we use this formula, and then we will get this kind of graph where ft is equals to 1 and 2. And then for question A2, we need to calculate the xt, and then we need to calculate the Laplace transforms ft, and then we have to let from 0 lower than t and then lower than ft is represented by xt. So, and then now ft is a periodic. This is the graph, and then our ft is a periodic, and then we will have to find the equation, and then after that we will get this equation at 1, and then we have to take the Laplace forms at 1. Then we have to do the calculation where we will get ft equals to this one, and then equals to 0, and then we will now take Laplace transform at a differential equation where we get y prime equals to negative 2, and then y we get equals to 1, and then we put on this value, we will get xt equals to this one. Okay, for the next question, for question B, where a series RL circuit is shown. This circuit where R is equal to 10, and then L equals to 2H. The source of the circuit given is Vt equals 2e negative t bracket t minus 1, and then H t minus 1. Okay. The first question asks us to apply the Kirchhoff's law to show that the circuit can be represented by the following equation, which is this equation. And then by applying RVL, we put on that equation. We put on the equation by using Kirchhoff's law. We apply, and then we put on values that is given by the diagram, where for L, R, and Vt. And then after that we will get di to dit plus 10 it equals to t 2e negative t bracket t minus 1, and then h over bracket t minus 1, which is similar to the equation that is given. And then it can be represented. The circuit can be represented by the following equation. And then to determine the current IT for the circuit using Laplace transform with initial condition where I 0 equals to 0. From the equation that is given, the one from B1, we will use it for the question B2 like this. We will get this one. We will get this answer. So we take the inverse Laplace transform to solve it, and then we will get the value at IT. For initial condition equals to 0, just like this. Alright, that is all. Thank you. Okay, hello. Now I will explain about the simulation for question 4A. This is the piecewise function for the simulation for question 4A1. This is how we simulate the piecewise function. And then next, for question 4, for B, this is how we simulate the equation, the question, and this is the value that we will get. That's all. Thank you.